guys, hello friends, hello G's, it's your boy again, Falling with a Star. So guys, today we are going to look at alkanes. So now let's start with the definition for alkanes. Alkanes are saturated hydrocarbons, saturated underlined, hydrocarbons underlined. When we say something is a hydrocarbon, they are compounds that contain only hydrogen and carbon. So if any compound contains hydrogen and carbon, that compound qualifies to be called what? A hydrocarbon. What do we mean when we say alkanes are saturated? Alkanes are saturated because they only contain single bonds between the carbon atoms. So the carbons are being bonded by single bonds. And that's why we say alkanes are saturated. This is what makes alkanes different from alkenes, because in alkenes you can find double bonds between the carbon atoms. You understand? And they are said to be what? Unsaturated. Now let's look at the general formula for alkanes. Alkanes are being represented by this general formula CnH2n plus 2. That means that if we know the number of carbons a certain alkane contains, we can actually predict the number of hydrogens it can contain. So let's say that a certain alkane contains 2 carbons. From this formula, you get to know that it contains what? 6 what? Hydrogens, and this is called ethane. We will see that later. When it contains 3 carbons, from this formula, you find out that it will contain what? 8 hydrogens, and this is called propane. 7 called what? Heptane. You understand? So now if you look at the definition for alkanes, the general formula. Now one thing we must note about alkanes is how they are being named, and their names are being derived from what? The number of carbon atoms they contain. So an alkane that contains only 1 carbon will have the root word met, and all alkanes end with this word ane. So met become methane. Contains 2 carbon atoms become ethane. Propane for 3, butane for 4, pentane for 5, hexane for 6, heptane for 7, octane for 8, nonane for 9, and decane for 10. Now let's look at how alkanes are being represented. Alkanes can be represented in 3 ways. We have the displayed formula, we have the structural or molecular formula, we have the skeletal formula. You must note this is very important. You understand? So let's look at this displayed formula. This is how we actually represent alkanes when it comes to displayed formula. So this is the displayed formula for what? Propane. It contains 3 carbons, as you can see. And one thing you must note that all carbons can actually form what? 4 covalent bonds. So you must actually have 4 bonds around each of these carbons. So let's count them. 1, 2, 3, 4. 1, 2, 3, 4 for this carbon. 1, 2, 3, 4 for this carbon. You understand? And one thing you must note that when the bonds around a certain carbon is not up to 4, you actually satisfy that by using what? Hydrogens. You understand? For example, when you have carbon, have this, and let's say that this carbon have fluorine attached to it, and this they have hydrogens. The number of bonds around this carbon is not up to 4, and therefore we use hydrogens to satisfy that. So you bring hydrogen here, you bring hydrogen here. So this is what I'm talking about. But this displayed formula is very bulky and lengthy. So we use the structural or the molecular formula to summarize it. So this is the structural or molecular formula for what? Propane. So you must note the difference. You understand? Very simple. This is the structural or molecular formula for what? Butane. And this is the displayed formula. We can also use the skeletal formula, and this is how the skeletal formula looks like. This is for what? Propane. For ethane is just a single line. For methane it's dots. You understand? And this for propane. This for what? Butane. You understand? So this is the skeletal formula. This is the structural formula or the molecular formula, and this is how the display formula looks like. You understand? So sometimes they might ask you to do one of them based on the choice of what? The examiner. You understand? So guys, let's look at isomerization. We actually have many types of isomerization, but the one that we are going to talk about is constitutional isomerization or structural isomerization. And this is further being divided into 3 types. We have chain isomerization, positional isomerization, and functional isomerization. But because we are actually dealing with alkanes actually shows what chain isomerization, but not positional or what functional. You understand? But before we even look at chain isomerization, what are constitutional isomers, or what are structural isomers? They are different compounds of the same general formula. Different compounds of the same general formula. When you talk about chain isomerization, actually for chain isomers, they actually contain the same number of atoms, or they actually have the same molecular formula or general formula, but they differ in how the carbon atoms are being bonded or how the carbon chains are being arranged. For example, let's take butane. Butane actually, I didn't bring the hydrogens because I want you to understand. This one way of representing butane, linear chain. Another way of representing butane is this. So this become an isomer of this. So this become isobutane. You understand? Someone can also draw it in this way, but this and this is actually the same. When you turn the paper, you see that this and this is actually the same. So this is the isomer for butane. When you look at pentane, this is one way of representing pentane, the linear chain. This is another way of representing pentane. You can see that they contain the same number of atoms, 5 carbons. They also contain the same number of hydrogens, but they differ in how the atoms are being bonded. You see that how the atoms are being bonded in this is different from this. You understand? So this become an isomer of this. So this become isopentane. There's another way of representing pentane using this. You see that the atoms are being bonded differently, and this is called neopentane. Put this in mind, neopentane. It's like a cross. Neopentane. This is isopentane. This is pentane. And all these are common names. We'll look at that later when we are dealing with nomenclature. When you look at propane, let me say this. Propane doesn't actually have an isomer. You understand? So there is no isomer for propane. There's no isomer for ethane. There's no isomer for methane. You understand? Put that in mind, because this and this is actually the same. This and this is actually the same. There is no difference. You understand? Yeah. So guys, now let's look at the physical properties of alkanes. For the physical properties of alkanes, we will look at the polarity, the boiling point, and also the solubility for alkanes. When you look at polarity, alkanes are said to be nonpolar. This is because the electronegativity of carbon and hydrogen are almost the same. You understand? Or the electronegativity difference between carbon and hydrogen is slightly negligible. Because of that, we say that alkanes are nonpolar. And because they are nonpolar, the atoms are being bonded by weak forces, and that weak force is called van der Waals forces. So the kind of forces between alkanes are van der Waals forces. This van der Waals forces actually increases with molecular weight. So as the chain length increases, the van der Waals forces also increases. So the larger the molecule, the higher the van der Waals forces. And through this, we can actually say that small alkanes will be gas in nature, large alkanes are liquid, and very large alkanes are solid, because as the molecule becomes heavier, the bonds become stronger. The van der Waals force becomes stronger. So small alkanes will be gases, large alkanes will be liquids, and very large alkanes will be solids. You understand? So now let's look at the boiling point, and also I'll use that opportunity to also talk about melting point. Because alkanes are nonpolar and the atoms are being bonded by weak van der Waals forces, they are said to have low boiling point. And this boiling point actually increases as the molecular forces or the van der Waals forces increases. You understand? That means that as the molecule gets bigger, the boiling point also becomes higher, and also the melting point becomes higher. So As the molecules get bigger, the boiling point and melting point also what increases. But one thing you must note is that branching actually decreases boiling point. So that means that if you have two compounds and one is linear, the other is branched, though they contain the same number of carbons, the same number of hydrogens, the one that is linear will actually have a higher boiling point than the one that is branched, because branching actually decreases boiling point. This is because branching decreases the surface area contact with heat, and because of that it decreases what the boiling point. But branching actually increases melting point, because branching actually cause the alkane to be packed into a crystalline structure, and because of that this increases its melting point. You understand? Now let's look at solubility. Because alkanes are non-polar and water is polar, alkanes are said to be insoluble in water, and they are also less dense than water, and because of that they float on water. You understand? Yes. Now I want to ask this question: what are alkanes used for? Alkanes are unreactive because the carbons are saturated. As I said, alkanes are saturated hydrocarbons. The carbons are saturated, they are satisfied, so they are unreactive. And also the carbon-carbon bonds are very strong. Carbon-carbon single bonds are very strong than carbon-carbon double bonds. Because they are unreactive, they don't actually react with acid, base, reducing agents, or oxidizing agents. These alkanes are used as fossil fuels like petrol. They can be used as gases. They can be used for paints, that's heavy alkanes. They can be used for candles, waxes. You understand? One thing you must note is that alkanes actually undergo two chemical reactions, and they are halogenation and combustion. Alkanes are flammable, so they undergo combustion reaction and also halogenation. So in the next part we are actually going to look at the reactions of alkanes and also the nomenclature for alkanes. Thank you.